So how the triangles are created and how things reference themselves through, there's that reference again. When we're dealing with what's called our unit circle, it's built off of the two special right triangles. It's built off your 30, 60, 90 and your 45, 45, 90. Okay? These two triangles create everything. And when we talked about this last week, I said that you only really need to know one thing. You need to know which of those three angles is the smallest. 30, very good. Which means which means the very first angle that I need to worry about. I'm going to worry about this quadrant for right now. Goof this all up now. You had one here. All I need to know is that this is 30 degrees. That first angle is 30 degrees. Then I told you guys that the only radian measure you have to know is that. 30 degrees as a radian is what? 1. Pi over 6. It's pi over 6. So 30 over 180 times pi. 3 over 18, 1/6. Okay. So what happens then is that you get these ordered pairs. And the way that this stuff is calculated, I want you guys to see. You technically are drawing down a vertical to be perpendicular to the x-axis. You create a 30, 60, 90 triangle at that value, which means there's my 60. So what you're working out to be then is that you can calculate your ordered pairs and where this is placed within space. The ordered pairs go cosine and sine because cosine comes first from the alphabet and x comes first from the alphabet for x and y. So your ordered pairs for the placement of this, because it goes cosine and sine. Well, what's the cosine of 30 degrees? What's adjacent to the 30? 3. What's the hypotenuse? 2. So the cosine would be root 3 over 2. What is the sine of 30 degrees? Pi over 6. 1/2. That places it in space then. Okay? It places it in space. You've got some horizontal distance, some vertical distance, and gone off. Just or not.
If like the unit isn't like 1, like x root 3 or...
Okay, if it's x root 3 and then you have a 2x on their hypotenuse, what's x root 3 divided by 2x?
X 3 yeah. I mean, I'm just saying like, so then...
As long as, that's why it's called the unit, because that no matter what I know where you're getting at. Someone else asked this earlier. With the scalar, there's no scalar. If there was a scalar, the scalar would be the same for both and it would just drop out. You're still going to be left with a 1 and a root 3. You'll still be left with a 2 and a root 3. Because that value of x, the scale, simplifies out.
So can we just like memorize
What? Well, you don't have, it's not even, no, the only thing you have to know is how to convert 30 degrees to a radian. Because everything else falls into place. Because you're right, you know your special right triangles from last year, hopefully. I know Seb beat you guys up with these things. All right? You know those. You can always rewrite them. You can always draw them out. Because if it takes you a second to remember, oh, what's my cosine? Cosine's my adjacent over hypotenuse. Oh, root 3 over 2. And so on. Now, as you go to the next ordered pair, the next value, the next one up would be 45 degrees. You agree? Okay. Yes. Now this one's even easier because we know the full revolution starts at 0 goes back around to 2 pi. We know here's the halfway point, so what was half of 2 pi?
1 pi.
1 pi.
1 pi.
What's half of that? And what's half of that?
Pi.
Pi over 4.
So that is pi over 4 up from the x-axis. First quadrant is all we need to know. First quadrant creates all of our special right triangles. First quadrant is where all of our positive reference angles will wind up. The only thing that's going to change are the signs SIGN as we flip them through the axis.
If we know that one of the lines is going to be a radian and the special right triangles, can we just solve about what to do? It was using cosine and sine.
You'll see. And that gives you, yes, sir?
The only reason that I'm having trouble learning this is because I don't understand how it's useful for dealing with these triangles.
You'll see. I'm just building the first quadrant. Because when we get into this, the triangles are what's going to allow you to figure out all the answers to the problems. All of trigonometry is built off of 2 triangles.
Okay, so this is going to help us learn how to do trig.
Yeah. This is the basics of all trigonometry right here.
Okay, all right. That's going to help. All right, then I'm okay with this. I was having such a hard time figuring out.
No, I know where you're getting at, because eventually we're going to do something like this, where I'm going to ask you, solve for x.
Okay. I can't do that, but
I know.
I get
And you don't need to use anything but this, because all that's built out of this.
Okay. All right, yeah.
Chimkey. Cosine. Cosine of 45 degrees is adjacent over hypotenuse, 1 over root 2. Root 2 over 2 when simplified. When you rationalize your denominator, you have 1 over root 2, so you multiply top and bottom by root 2. Square root of junk times square root of junk is junk, you get root 2 over 2. Yes, sir?
So for the 60, all right, 36 to find that one point, you use the cosine is x and sine is x, or sine is y.
Correct.
For the 40, and you do the same thing for the 45 and 45 minutes?
Yep.
Okay, so does that work for the 45, 45 minutes? Does that mean that works for, oh wait, no. Okay. Okay.
What's the next angle? 60. Pi over 3. Do you need to worry about converting pi over 3 into radian? Going from 0 to 30, you go up how many degrees?
Wait, what did
You go, what's 30 more than that?
60.
What's 30 more than that? What's 30 more than that? 30 more. 30 more.
70.
So each time I go up by 30 degrees, I'm going up by 1/6. I'm leaving the pi out for 1 second here. Watch what happens. 1/6. 1/6. 2/6. 3/6. 4/6. 5/6. 6/6. 7/6. 8/6. 9/6. 10/6. 11/6. 12/6.
Why didn't you say that?
Okay. Again, now watch this. I went up 1/4, right?
Yes.
1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4.
Makes so much
Everything goes around by the same fractional amount. All you need to know is what's the smallest of the 3 angles. 30. If you know that, everything else just is incremental. It just goes around. Okay? It just goes around. Pi over 3, 60 degrees. What is your cosine at 60 degrees? When you're at 60 degrees, what's your adjacent? It's 1. What's your hypotenuse? 2. So what's the cosine of 60? 1/2. Sine. Okay. Unit circle starts at 0, has a radius of 1. It's a unit. So at 0, my ordered pair is, oops, I went out 1 and I didn't move up any. 1, 0. So therefore, what's the cosine value of 0?
0.
What?
1.
Oh.
Go up to pi over 2. What's your ordered pair? If this is 1, 0, what's my ordered pair up there? 0, 1. Very good. Very easy reason why we don't do trig functions at 90 degrees and whatnot in geometry. Bless you. If I'm at 90 degrees, what's my opposite? What's my adjacent? I'm sorry, what's my opposite? What's my hypotenuse? Excuse me.
Oh, there is, that's like.
2. What's 2 over 2?
1.
So what's the sine of 90?
1.
Even on here, what's the sine of 90? Root 2 over root 2.
1.
1. Cosine, if I do cosine of 90, I don't know which one is my adjacent. I don't know which one is the adjacent. It's just 0. Okay. Same thing with sine. Sine of 90, I don't know which one's my opposite. I don't know which. All right, goes. So basically what I'm getting at here, guys, is that this whole quadrant just reflects and it drops into other quadrants, because think about ordered pairs in the standard Cartesian plane, two-dimensional plane. Both x and y are positive here. What are they here? Negative, positive. What are they here? What are they here? So if I take this 30 degrees, pi over 6, reference angle, over here I come up pi over 6. What's pi over 6 less than a whole? 5 pi over 6. Okay?
Oh, geez.
The only
wow.
thing that changes is I come across, see how it's still parallel to the x-axis? Does my y value change? No. If it's parallel, if it's horizontal, its y value doesn't change. So I know that I'm still going to have 1/2 for my sine value. But what changed to reflect it over, as this still has the same exact idea of a 30-degree reference angle, the adjacent value here becomes negative because you went to the left, the way I was pointing. Okay? So that's why your cosine value is negative root 3 over 2, because you're in the second quadrant. X values are negative. Cosine of 30 degrees is negative root 3 over 2. I want you to build the rest of this tonight. All of it.
All of it.
Degrees, radians, ordered pairs. Build it.
Is that our homework?
Yeah.
Well, don't we already have the degree?
Well, yeah, you probably have most of it already done. Okay? I don't want you to look at a book. I don't want you to look at your notes. I don't want you to do anything but use what we have on here now. And I want you to build all of the other degrees, radians, and ordered pairs just by reflection and thinking about reference angle. I'm up here, or if you want to count it by 6ths or 4ths as you're walking around. I will say one thing, it's going to be quicker if you start using the reference angle. I mean, for example, the next one I have to go up a quarter. What's a quarter less than a whole?
3/4.
3/4. What's a quarter more than a whole? 5/4.
Yeah.
Same idea. Reference angles allow you to bounce and reflect within the quadrants. Build it tonight. If you build it, it's really nothing to build to it. But yeah, this will allow us to do stuff tomorrow in relation to the trig functions, the 6 trig functions at any given point on here. So if I wanted to find the 6 trig values at 5 pi over 4, I can find the sine, cosine, tangent, cosecant, secant, cotangent at all those values, as well as what's on the quadrantals, ordered pairs and stuff. Yes, sir.
Never mind, that's my question.
Good conversation.
What's the top dotted line?
Oh, I just showed this one here. I just showed how you just come across horizontally. This is horizontal, so if it's a horizontal line, it shares the same. Oh, it shares the same y value. If it's a vertical line, it shares the same x coordinate. Horizontal line shares the same. That's how that all works.